all the noise from your service. Your service quality will become the best after it regenerated. But the disadvantage of electrical regenerator is it can only regenerate one signal once a time. WDM system is a very special system. In one fiber, we have a lot of wavelengths, up to 80, 160, and 192 wavelengths. Okay, we have a lot of wavelengths into the same fiber. If you want to use electrical regenerator, then the regenerator station will become very huge. They need 80 regeneration unit or 160 regenerator unit, which makes this regenerator unit station is very, very expensive. So we don't want like that. So we choose another solution. Another solution is optical regenerator. We discovered one unit. We give it the name called optical amplifier unit. Optical amplifier unit, it can amplify your signal power directly. He doesn't care how many wavelengths you have in the same fiber. He can amplify all of them at the same time. So in the regenerator station, we just need one regenerator. Optical regenerator board can realize the all wavelengths power regeneration. So this is very, very good for us. So we like to use optical amplifier in our network. We call it OA. Okay, but also we have one special, that is, OSC channel will never be amplified by the OA unit, because we want, if the OA unit is failed, our OSC channel is still okay. We can still get the power. We can still get the information by OSC channel, right? So we want OSC channel's ability when the OA is failed, right? So you can see in our WDM structure, before our service signal be amplified, we will drop the OSC channel into OSC board, right? And after the service being amplified by optical amplifier, we use a new OSC channel mounting blanket into the service signals and transmit to the destination station, right? So after service arrives at the destination, you can see we drop the OSC channel firstly. Then service will be sent to watch unit optical amplifier, because after long distance transmission, optical power will be decreased a lot. If at this time we do not amplify it, we just connect it to the OD, what is optical demanding transfer unit directly. This OD is like oil, the same stuff. This OD is very good. Optical demanding transfer can drop all the service from the main path at the same time. It's very good. But for this unit has one disadvantage, that is the insertion loss is very high. The attenuation is very high. If our service, our service already transmit a very long distance, the power is already too low. If I don't amplify it, I connect with OD directly, the signal will be decreased a lot. OTU maybe cannot receive it, cannot detect it, right? So before we use OD demultiplier or signals, we need optical amplifier in the sink station to do the amplifier to make your service signal a little higher. Then we can do the demultiplier. So we have OD and OA and OD in the destination stations, right? And OD will drop all the wavelengths and give it to different OTU. Depends the frequency, okay? Frequency. Which frequency for which OTU will be connected by the fibers, right? And then you can see in our system structure we have some stuff didn't finish. You can see we also have TU-ALU over here. What is TU-ALU? TU-ALU is like OTU. OTU has two parts, client sides and the WDM side. For this kind of unit, it will be very dangerous. For example, if for the first OTU board, the WDM side, the interface is broken, So what we should do to do the troubleshooting? The only thing we can do is we need to go to equipment side, use a new board to replace the broken board. Then your service will be restoration, right? But we don't have any solution to fix your service, right? So we thought it's pretty dangerous. So we cut the OTU board into two pieces, make it become TU and ALU. TU only has client ports. ALU only has WDM ports. TU connect with client equipment directly. ALU connect with WDM site directly. Okay? So if the TU accesses a service from the customer, it will, after he receives it, he will cross-connect the service from TU to one ALU. If at this time the ALU is broken, at this time we can delete the old connection between TU and ALU and create another connection between TU to another ALU. And this connection is software. You can modify it by the engineer. You can create it, modify it, delete it, right? So the service can be protected by this kind of application. So now in our WDM network, TU and OU is widely used in our WDM. It's already replaced the OTU. OTU we still have it, but not as big as TU and OU. Okay, so it's kind of this way. And the connection between TU and OU, we use one board we call close connection unit to realize the connection between TU and OU. Okay. So, and also we have another thing. You can see the last one, optical supervisory channel and electrical supervisory channel. Okay, this also told us our WDM systems support two different supervisory channel transmission, optical supervisory channel. Or if you don't want to use optical, you don't want all the OSC board, you can use electrical. If you use electrical, all these supervisory channel will be added into your signal, service signals. We have a lot of overhead transmitted with your service signal. So here, those overhead will be carry your supervisory channel and transmit with your customer service. Okay, so it will be like this way. Okay, when your customer service be detected during this transmission, the ESC supervisory channel will be detected. Okay. And you can see this time, we announced another problem for you is, in the middle of this system structure, we have one regenerator unit station, that is optical amplifier unit. This optical amplifier only amplifies the power for your service. It does not detect your service, right? So, because it does not detect your service, the ESC overhead cannot be detected. Okay. So ESC cannot monitor the status of optical amplifier station. That's the disadvantage of ESC. OSC, it can monitor all the stations in core WDM network, but ESC, only optical amplifier station cannot be monitoring. Okay, so that's the basic system structure of our WDM network, right? And also our WDM network supports two different transmission modes. The first one we call single fiber unidirectional, which is widely used. In this application, between two stations, we will have two fibers, one for sending direction, another one for receiving direction. Each fiber only transmits one direction signals. Two different directions will never affect each other. Okay, this is widely used in our network. We have another application that is single fiber bidirectional application. For this application, the sending direction signals and the receiving direction signals will be mixed into the same fiber, and you need to use different wavelengths to carry sending signals and the receiving signals. Otherwise, they will affect each other. Okay, so you should know one thing: in the same fiber, you cannot use the same wavelengths to carry different service. different service means different direction, different customer service. Okay, so single fiber unidirectional, bidirectional will be like this way. It's not widely used as single fiber unidirectional because in single fiber bidirectional, so there are too much request for your hardware. For example, your mounting planks, demounting planks should be the unit which is mounting planks and demounting together into the same unit. Okay, and you need half wavelengths for sending, half wavelengths for receiving. Your capacity will be only half. And in the middle of this system, the amplifier station and can amplify the signals for both directions. It's very hard to use this amplifier. Okay, so actually in our real network, single fiber unidirectional is widely used, and it's used for high capacity, long distance. Okay, and a single fiber bidirectional signal can be used. It's not widely used as single fiber unidirectional, but it can be used for some small capacity, shorter distance application because it's very cheap, and also it can supply the WDM technology for some lower request places. Okay, this is two different application, and also we have two different application mode. The first one is a integrated system. Also, we can open system. Okay, integrated and open system is widely used in our network. Okay, integrated system do not has any request about the client device or client customer. Any signals can be accessed by OTU board. Okay, and OTU can use standard wavelengths to carry those client service. He don't care what kind of service he access it. Okay, but we have another mode. So this is widely used. No more now. Almost all the WDM system use this open system or integrated system. Okay, so let's do a summary. The advantage of WDM. Okay, first one, ultra large capacity and ultra long transmission. The large capacity, how large it you can consider like that. Now the maximum capacity for WDM level is we can transmit 80 wavelengths at the same time, and each wavelength can use to carry 100. Maybe in a few months later you will see each wavelength carry 400. So the capacity is very high. And a long distance, you can use a lot of amplifier in your network, make your WDM system transmit to thousands of kilometers. Very, very long. Okay. And the second, transparent data transmission. The WDM do not care which kind of customer service you give to him. He can transmit it directly without configure any customer service, including ATM, SDH, IP, Ethernet service, or 3G service. Any other service can be carried by WDM. It's very good. Maximum investment protection during a system upgrade. We can upgrade our system and we can get a very good protection with our network. Okay, and a high networking flexibility and reliability. For this kind of application later you will see we can supply a lot cross connection for WDM network. Optical cross connection, electrical cross connection can make your WDM service go to any direction, carried by any wavelength or something, right? That is very, very good. Okay. Okay, so that's almost all the advantage of our WDM. Okay, so let's continue with next sliders. We already learned what is WDM and the transmission mode, the application of our WDM, and the system structure of our DM, right? So actually the WDM, if we want to use WDM in your real network, we still have two different application can be used. The first one is this one, CWDM. The CWDM, the name of CWDM is
coarse division mounting plan.